Radical expression with the same indexes and radicand are like radicals. To add or subtract like radicals, you use the distributive property. So that's a distributive property. So now if you want to add these two radicals, first of all you want to make sure that they are same number inside and they have the same number in the cap. So same radical and same radicand numbers. So the indexes and radicand should be same or like. So in order to add these, you assume that there is a number that is in front of it is 1. So you're going to add the front number, that's going to be 8, and this number remains same, that is 4th root of 10. Is similarly like 1x plus 7x, that's going to be 8x. But that x has to be exactly the same in both of them. For the next one, you're going to add the front number, and that are going to be 2 and 10. So 2 plus 10 is going to be 12. 8 to the power 1 over 5, and that's your answer. Next number, we cannot add these two together, although they have a same index, but they do not have a same radicand. If we are able to make this one same as 2, then we can add or subtract. So let's see if we can do that. So we can write this as 27 times 2, because 27 times 2 is 54. Now we are going to write it as cube root of 27 times cube root of 2 minus cube root of 2. Cube root of 27 is 3. So cube root of 27 is 3. 3 cube root of 2 minus 1 cube root of 2. So there is a 1 in front of it. If there is no number, then there is a 1 in front of it. So you're going to subtract the 3 minus 1. That's going to be 2 cube root of 2. For number 10, you're going to write in front of it is 1. So 7 minus 1 is going to be 6 fifth root of 11. 4 plus 8 is going to be 12. 9 to the power 2 over 3. And in this case, you're going to have cube root of 5. And you can get this one as 8 times 5, that's 40. Cube root of 8 is 2, that's outside, and inside you're left with cube root of 5. There is a 1 in front of it, so 1 plus 2 is 3. Next, we're going to do example number 8, adding and subtracting variable expressions. For letter A, you're going to add the 5 square root y plus 6 square root y. You can add these two numbers because the radical index number and the radicand are same. So 5 plus 6 is going to be 11 square root y. Now for the next one, you have the cube root on both of them. So that's the index is same. But inside you have 2z to the 5, and here you have 54z squared. If we can make the inside number same, then we can add or subtract. Otherwise, we will not be add or subtract these two radicals. So we're going to write it down or rewrite it this as 2z to the third, z to the second minus z, and you're going to write down 27 times 2 z square. Now for this one, z cube and cube root induce each other, so this z comes out. So you're going to have z out, and inside you're going to have left with 2 and z square. So this 2 and z square will be inside, and the cube root of z is z, that is outside. Now you're going to find out what you can take out on the next one. So in the next one you have a cube root of 27. So the cube root of 27 is 3. So the 3 comes out, and inside you're left with 2z squared. So ultimately what you got here is 12z cube root of 2z squared minus 3z cube root of 2z squared. Now you can see that the 12z and 3z are like terms, and these two are also like. Now we can subtract or add whatever it is given. So 12z minus 3z, and that's going to be 9z cube root of 2z squared. So in example number 8, sometimes you have to make the same radical in order to add them, but sometimes it's given in a simplest form, in a like term form, where you can add them directly without making any changes. So for example, 6 plus 2 is 8. Since these two radicand are exactly the same, cube root of x, cube root of x, so we could add them together. So it's going to be 8 cube root x. Whereas in number 2, we have to make some changes in order to make them like terms outside, as well as a fourth root of the same number inside. If we can, then we will make it. If not, then we cannot add or subtract. So for number 2, we are going to write down 16, fourth root of 3, and we are going to break the p to the power 6 as p to the power 4 and p to the power 2. Remember, we need a same power, that is the number outside, so that we can induce each other. And then the next one, we are going to make it as fourth root of 16 times 3 p squared. Now for the first term, you're going to induce the 4 with 1 over 4. So the 4 and 1 over 4. So 4 and 1 over 4 cancel each other. The p comes out. So that's going to be p. Inside you're left with 3 and p squared. So it's going to be 3p squared. And for the next term, you're going to find out if you have a fourth root of 16. So the fourth root of 16 is 2. So it comes out of the radical. And inside you have 3p squared. Now if you notice that the outside term are like terms, and this is exactly the same. So now we can subtract 16p minus 2p, and that's going to be 14p. Fourth root of 3p square. For number 16, same thing. We're going to find out the cube root of 9, and it's going to break as w square, and w. So that makes it 2 plus 2 plus 1, that is w to the power 5. The next one is w, and you can break the 3 as w to the power 2 and w to the power 1. Now square root of 9 is 3, that is outside. Square root of square is w, 1 w is out. Square root of w square is again w, another w out. And then when you left with is square root w, that is this w inside the square root. In the next one, square root and square cancel, so 1 w out, another w will be staying inside. So what you got here is 3w square square root of w minus w square square root of w. Now you have this outer term or like term, so 3w square minus w square is going to be 2w square, and w square root and w square root are like terms, so you're going to get here is 2w square square root of w.